So now we go to butter. This is also a very popular product in the market. Milk, you remember, 4% of fat. This is oil in water emulsion. Now we go to cream, around 4 to maybe 60% of fat. Also oil in water emulsion. Now we go to butter. Butter has around 82% of fat, much higher. And it's no more on water emulsion. It's become water in oil emulsion. So in making butter, there should be a step that we convert this emulsion into the opposite emulsion. And we do that by churning up the cream. In the previous product, we see the term whipping, and now we see the term churning. If we translate in Vietnamese, both will be the same, là đánh kèm. However, in English, this is not the same. Whipping is like when you whip, you introduce the air and you keep it there. Churning is somehow like over whipping. You go further. You beat your cream further to obtain the product butter. Okay, now we look at the food legislation. Butter should have at least 82% of fat and only the fat from milk. If you make fat from other source like plant fat or oils, then you have to use another name, not butter. Maybe you use a name like plant butter or plant-based butter and so on, not butter alone. Because if you use the butter alone, then this word is already preserved for milk fat. And butter contain at most 2% of solid non-fat, other dry matter content but not fat, and at most 16% of water. There are several types of butter, can be sour or can be sweet one. Sour means that in the making they apply fermentation or they add with some acid, they add some additive. Sweet butter means in the making they do not do fermentation, so the taste is original. It has a slight sweetness, right? Salted versus non-salted butter. In salted butter, then they add some amount of salt and the product tastes salty. These are the good properties of butters, what we want. The color and the appearance of the butter. The color comes from the color of beta-carotene, a component which is soluble in fat. The appearance is smooth, matte surface. The surface is very smooth, fine. The flavor comes from the milk fat, come from the phospholipids, or come also from the starter coater if we do sour cream, for example. The textures and the mouthfeels come from the melting grains of fat, come from the globules characteristics of fat. The spreadability, so butter can be spread in cold condition. So you put butter in a fridge, it looks solid, but it's not very solid. So you can spread it with a spoon, with a knife. You can spread it on your sandwich, on your other food to eat. So we look at the texture later. How can we do this? If you remember, when we look at the melting range of fat at 5 degrees C, part of the fat is crystalline solid, but the other part is still liquid, meaning it's still soft. And later on, you will see that butter is actually also contain air bubble. Why air bubble? Because we apply churning. Churning is like similar like whipping. I mean, we introduce the air. So there is air inside as well, so we can spread the products. And butter has quite a long cell life, yes, because the low water activity, low moisture content, low water activity. This is a structure of butter. Fat globules, these are the fat globules. And during churning, part of fat globule get broken. For example, this one, the fat globules are broken. So the fat is released out and then they link together. Now this white background is actually fat, not water anymore, but fat. And now the water is in dispersed phase. In an emulsion, you have a dispersed phase and you have a continuous phase. In cream and in water, the emulsion is oil and water, mean oil is in the disperse, but butter is water in oil, so water is in dispersed phase. So you see it is dispersed, it means it's not continuous, it's discontinuous phase. Here is the aqueous, where is that? Here, aqueous droplets. Droplets containing water and many other components as well. So the network now is fat become continuous. And we have also air bubbles, air cells inside as well. The procedure how to make butter. From raw milk, we do pasteurization to make a safe product. We do cream separation to have cream and to have skim milk. And we do butter from cream. Now we have to do heat treatment again, and the temperature is quite high. And again, because the product is rich in fat, so we have to apply this heat treatment to inactivate lipolytic enzyme to prevent the rancidity. And then, if we do sour butter, fermented butter, then we do fermentation here. But for normal sweet butter, we just go this way. And then in this step, we do ripening or aging. It's actually we just store our cream at low temperature for a period of time. Why do we need to do this? So that the fat will crystallize. So the fat globules will become hard. When they are hard, when you churn them, they hit each other and they get broken. If they are melted, if they are not hard, so they will not get broken easily. So this step, we need to crystallize it so they can get broken when we churn. And now we do churning. We break the fat globules. After churning, we will obtain two fractions, buttermilk and butter granules. How you call this here exactly? What do you obtain here? Butter granules. Là hạt bơ. Yeah, we will see the image of granules later on. And then we do the separation like a filtering to remove buttermilk. So buttermilk is the byproduct of making butter from cream. Because, for example, from cream here, you have what? 40% of fat, 60% of skim milk, means a lot of water. But in butter, you have 82% of fat, only 16% of water. From a lot of water, now you have less water, so water should be removed. A certain part of water and the soy component inside the water should be removed, and that is actually the buttermilk. Okay. So now we go to working, kneading, like mixing, kneading là nhào nén lại. So to really make good structure for butter. And then we do shaping, forming into different shape and slicing and so on to have commercial products. We just discussed several important steps. Cream separation, we discussed in chapter 6 already. In the processing, there is also the aeration process. This is to remove the air to have better oxidative stability. And the heat treatment is to destroy microorganisms but also to inactivate enzymes. And then the ripening or aging. If we do fermentation, if this is for fermentation to make sour cream, but for normal sweet butter, sorry, this is for making sour butter. We do fermentation or adding with additives. But when we do normal butter, sweet butter, so we just maintain at low temperature. Okay, so there are several procedures here they make. We call this anaerobic procedure or the other procedure. They cool down the cream, but not at one temperature. Sometimes they change it a little bit, colder and warmer and colder. Just the purpose is to crystallize more fats so that they will hitch, they will break easily when we do churning. Okay, and the next step, important step, is the churning. What happened during churning? The emulsion will be converted from oil in water into water in oil. We apply intense mechanical movement with air inclusion. We mix it, we beat the creams, and the air is also included inside. Kind of over whipping. So now the fat globules are broken and the fat come together. We can clump together. So become butter granules. The end product of churning, we have butter granules and butter. So we do separation here. We take the byproduct out. And this one we will do mixing, kneading, and so on. So we have the butter. Just some example, okay? Here is the cream we already put in the fridge overnight. So it's already cold, and here we do churning. If you stop here, then you have actually whipped cream. The cream after being whipped. You see the volume is increased, the color look whiter because a lot of air bubbles are included inside. But for making butter, you don't stop here. You do over whipping. When you rotate, you mix more, and you see that now the fat globules are broken and clumped together to form like this, and this is called here. It's linked here, and these are called butter granules. And if you look at the bottom, you see the white liquid. It's actually that is buttermilk. And then you take this one out. You do working, you do kneading, and then you form in the shape of butter. If we look at this one, this is the machine system illustration how to make, and here you have churning here. When we do churning, we have the granules and we have the buttermilk. The byproduct will go down here. The buttermilk will go down here, and the butter granule will go this way. And we have a screw here. The gap or larger becomes smaller, 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 and it will compress. It will mix or knead the butter granule to form good texture, and here is formed into shape and cutting, so you will have like piece of butter. This is also similar. You just look and understand for yourself. Now buttermilk. What is buttermilk? Is a byproduct in the making of butter from cream. The fat content is low, 0.5%, lower than the fat content of milk. However, this fat is special because it is rich in the lipid from the MFGM. MFGM lipids means mostly polar lipids. Okay. If you see that the membrane, when they get broken and piece of the membrane will be oriented to the buttermilk. And buttermilk is rich in polar lipids. So polar lipid is sensitive to oxidation because it contains higher ratio of unsaturated fatty acids, so more sensitive to oxidative. And of course, buttermilk, why they call it milk? Because the composition is similar like milk. It's from skim milk actually. Why they call it butter? Because it's a byproduct from butter, but the composition is not very much different from milk. Only the fat is different, but the other part is kind of skim milk. And then of course it's not stable against microbial because it's rich in nutrients. And the buttermilk is also applied in making a number of products like applied as browning agent in baked goods, emulsifiers in eye cream, flavor in some other products as well. So actually this product has a good point, is that it's rich in polar lipids, the lipids that we normally do not have enough. The neutral lipid in the center of the fat globule is actually a lot. We have already more than enough. But the lipid on the membrane, the polar lipid, we don't have enough, so this product can provide us with that. Right, so we are already finished with buttermilk. Now we go question and answer so you can understand more.